This video we are going to do the same calculations we did in our previous video, but not using ratios, but using chemical formula that is given to you in the data booklet, because I have to teach you how to use these questions using formula as well, because some of your teachers might tell you, oh, I don't really like you using ratios to do these questions. Instead, use the chemical formula from the data booklet. Look, both methods correct. Your teacher cannot say it doesn't look nice to use formulas. It doesn't look nice to use ratios. Using ratios, totally fine. However, though we use both the methods, then it's going to be really it's going to be a good understanding. You will have a good understanding by using both methods. That's what I was meant to say. All right, now do you remember the formula from the data booklet that we can use to do this calculation? Okay, turn to the page. I cannot exactly remember the page. You have a data booklet. I'll give you the formula. The formula that we are going to use to do this calculation is called delta H. Yeah, delta H is equal to Q over N. All right. Now this can be found in the data booklet. So what is delta H? Delta H is the enthalpy change according to the data booklet. So this is kilojoules per mole. If you are going to use this equation, it is important that you find the delta H value per mole of the substance. All right, per mole of the substance. That's the enthalpy change. All right, that's the enthalpy change. The enthalpy change. All right, this is the enthalpy change. So Q is the energy. Q is the energy released or absorbed for a fuel. It is the amount of energy released. It's in kilojoules. Okay. Now this is the number of moles of the substance. If there is if you are going to calculate the energy released when you burn certain number of fuels, so that N is the number of fuels. Okay, it's in mol. All right. Now let's try to use this equation so that we can use I was meant to say let's use this equation to do these questions. Man, it is too late. Okay, what's the first question? Calculate the energy Q in kilojoules for 5 moles of NO. What? 5 moles of NO. So in other words, the question saying when you react 5 moles of NO, what is the energy that is going to get released? In order to do that, you have to rearrange this equation. So let's rearrange this equation. Equation Q is going to be equal to delta H times N. All right. Now Q of what? Since this Q is related to NO, let me say NO. Okay, and delta H is this value, but you have to be careful using that value. All right, let me get back to you on that just after finishing this. Okay, so N is again number of moles of NO. So now it seems like it's a matter of plugging those values, which is going to be equal to delta H. Are we going to use 114? Are we going to use 114? No, you cannot use 114. If you are going to use the data booklet equation delta H equal Q over N, you have to get this delta H value for 1 mole. Unfortunately, your teacher is not going to give you this equation for 1 mole. Now, as example here, it is given to you for 2 moles. Then you need to work it out in your head or somewhere else for 1 mole. Delta H value for 1 mole. See, you have to lock. Remember, you have to lock the number of moles to the energy. But then again, you are using this equation. Delta H value should be used for 1 mole. So for 1 mole, it has to be divided by 57, isn't it? 57 kilojoules, right? Minus, because delta H has to be minus it's minus here because it's exothermic reaction. So you have to use those sign, positive or negative, in this case negative. Now number of moles is 5. Okay, so then the answer is going to be in kilojoules. So what's that? This minus 285 kilojoules. Now compare this answer with our previous answer where we did the same question using ratios. You should be getting the same answer. So listen to me carefully. I don't really like this though, this formula, because that can confuse you. Sometimes you forget to work it. Sometimes you forget to get the delta H value for 1 mole. Yeah, so you will end up using 114 and get the answer wrong. Listen to me carefully. If you are again going to use the data booklet equation, you have to make sure this is delta H. You work out the delta H for 1 mole. Is that clear? All right. Now, as I said, I don't really like this formula because you might end up making mistake. That is why I'm going to give you my version of the formula. Not just my version. Some of your teachers will give this version as well. Some of the teachers will give you this different version of this formula as I'm about to give you. If you use my version of this formula, you are not going to get it wrong. Okay, let me give you my version. So give me the version. Okay, all right, I'll give you the version. Okay, so this is the version I want you to remember. So in my version, this is what you will see. Let me get a delta H of the equation, or given equation is equal to the Q, the energy, over number of moles times by the coefficient in this coefficient of the substance according to the balanced chemical equation coefficient. Is that clear? So this is the coefficient, in this case the 2. All right, now this is the version of the formula I want you to use. If you use this formula, you are not going to get anything wrong. All right, so what we are going to do, we are going to use this version of the formula and see we can, and we are going to get the answers. No, accurate answers. We are going to get the answers correct. We are not going to make any mistake. So okay, let's go back to that question. Question 1, Q in kilojoules for 5 moles of NO. So what I'm going to do, Q, all right, this is to 5 moles. Now look what I do. Delta H of the equation, I rearrange it. Delta H of the equation times the number of moles, in this case the number of moles of NO, because we are trying to find out the energy related to 5 moles of NO. So look, what is the delta H of the equation? Look, minus. Oh, sorry, you silly. What, you forgot to divide this by the coefficient, COE. Coefficient. All right. So in this case, what I would do, QNO, right? What is the delta H of the equation? Minus 1114. What's the number of moles of the NO according to that, which is 5? Coefficient of the NO, as you can see, the coefficient of the NO is 2. So divide by 2, then you get the same answer. This is minus 285. Now, I forgot to tell you, don't leave the answer in minus though. Forgot to tell you, in any case, don't leave the answers in minus. They are asking you amount of energy released, right? So, because there are no minus energies, it says release. So, it is important you make another statement saying, therefore, 285 kilojoules are released. When you make that statement, I think you'll be fine. Don't leave the energy negative value. All right. Look, we did that question using what? using derived version of the data booklet formula, which is going to be the best way of doing that. All right, now we are going to do the question 2 using the derived version of the formula. Okay, now I need to clean the board, right? Cleaning will take time. All right, so okay, I'm going to clean the board. Let me clean the board. Now I'm ready to do the question 2. Okay, question 2 is asking you find out the number of moles of oxygen needed to produce 500 kilojoules. In this case, we need to rearrange. Okay. What you need to rearrange? We need to get the number of moles. So we write number of moles of oxygen, right? NO2 is about the oxygen is equal to what? Q, energy, coefficient of oxygen, because the coefficient of oxygen is something, it's all about the oxygen here. So N Q coefficient divided by the delta H, right? So now to do these questions, okay, so needed to produce, okay. Now to do this question, what you need to do, get the energy. What is the amount of energy that we are trying to produce? Q is 500, so it's negative 500 because energy is going to be released. If you are going to use this equation, it is better to put negative there. Coefficient of the oxygen is what? It is 1, isn't it? It is 1. Coefficient of the oxygen is 1. So the delta H is minus 114. As you can see, when you do this question, when you solve these numbers, when you put these numbers into a calculator, you get the answer. Minus cancelled out in moles. So that is how you do this question. I cannot do this part in my head. Use a calculator and get the values. Is that clear to you? Now, so this is how we do questions related to thermochemical equation, or in other words, how we do energy calculation questions related to thermochemical equation using the derived version of the data booklet formula. Okay, most teachers will encourage you to do the derived version than the just the data booklet one, because data booklet one might you might end up making mistake using the data booklet one. Is that clear? All right, so what we are going to do in our classes, we'll do more practice questions related to thermochemical equations, right? I think that's all for the time being. Love you for loving chemistry. See you soon. Bye bye.